Hello all. Today we are going to discuss about genetic algorithm and its use cases. So brief introduction about me. I have around 5 years of experience in data science and analytics, and I have a specialization in both machine learning and deep learning. And I have worked on different domains such as finance, manufacturing, retail, healthcare, and etc. Today's agenda will be first we will see introduction, then overview, then some basic terminologies, then after operators, and thereafter we'll see advantages and disadvantages of genetic algorithm and some use cases of genetic algorithm in real world. So introduction to genetic algorithm. So what is genetic algorithm? Genetic algorithm was developed by John Holland in 1960 and by his student in Michigan University. And these are generally based on Darwin's theory of evolution. So where it is a bio-inspired one, Darwin's theory of evolution says is that the survival of the fittest. Okay, the one who is the fittest one, who is going to survive and who is going to reproduce his child, then his genes are transferred to the child. To find the solutions to issues when deterministic algorithms are too expensive, that is nothing but when generally traditional algorithms what we use when they are becoming too expensive, then we go for this genetic algorithm. And these genetic algorithms are also easy to apply and find a solution. And also genetic algorithms are also known as a heuristic algorithm. That is nothing but it finds the solution in a given optimal way. So that's what the heuristic is means. Maybe the solution may not be the perfect one, but it will fulfill the agenda. So this is all about the brief introduction to the genetic algorithm. Now let us understand what exactly and how this genetic algorithm works. Okay. So as I said, this is a bio-inspired one. So this is a survival of the fittest one. So generally what happens, first we will take the two species or else two genes. Okay. Here we have taken two tortoise. Okay. Here we can see that out of these two individuals, we will select the best one. Best one is generally based on the fitness function that we will discuss in a brief after a while. So once the fittest one is selected, thereafter what we will do, we will do the reproduction now. Okay, so that the fittest one will try to do the reproduction, then it will give us to a birth to a new child. Then we will try to do a mutation onto this. What is mutation? We will discuss in a while. And after the mutation, what that comes up is a new generation. Generally, these new generations are much better and versatile than their parents. Okay, so here we have taken some initial sample of the two tortoise, and out of which we have selected the fittest one. Then after that, we are going to do the reproduction. Then thereafter mutation, and after the mutation, whatever it becomes is a new generation. Generally, this new generation is fitter than the previous one. So now let us say to how do genetic algorithms differ from the traditional algorithms. Traditional algorithms is nothing but like you can say the machine learning and some other basic algorithms. Those, and it is basically it is much different than these traditional algorithms. Generally, traditional algorithms requires more information. You can see this in machine learning. It is a data hungry. Okay, it requires more information. As the information increases, then the accuracy of the model also increases. And also, traditional algorithms cannot work in parallel, but genetic algorithms can work in parallel. You can say that in machine learning also, if you produce if you give one input, then only the output will come properly. So it is like that. So even in genetic algorithms requires less information, then also it is work fine. And traditional algorithms can only produce one final solution. Okay, it can produce many final solutions in genetic algorithm cases. So these are the basic difference about the traditional algorithms and genetic algorithm. So now let us head to the overviews. Overview is nothing but what are the terms and terminologies used in genetic algorithm, and out of which here we have to remember the two concepts. One is variation and one is the survival of the fittest concept. So survival of the fittest concept is nothing but that is a Darwin's theory of evolution. So in variation is nothing but how the population is varies. Okay, how different in their genes, how their property is different. Okay, that is what called variation. And survival of the fittest is the one who is the fittest one is has a chance of living, reproducing, and passing their characteristic to the following generation. So this is what the overview, and overview in this overview we have like some technical terms like selection, reproduction, and mutation. These we will see in a while. This is about overview. So now let us head to the some basic terminology. Okay, here you can see that there are three terminologies generally which is used in genetic algorithms. So gene, chromosome, and population. Okay, gene is an individual cell. You can remember like this. Gene is an individual cell. What is chromosome? You can see this. Chromosome is a combination of genes. Okay, 1011. All these are a combination of genes. So this whole became one gene. Sorry, one chromosome. Okay, gene is individual cell. 101. These all are genes. So what is population? Population is a combination of chromosomes. Okay, multiple chromosomes combined to give a population. So this is what the terminology is used in genetic algorithm. So you can see this here. Genes are constructed of a DNA sequence that are arranged in one after the another. So genes are constructed of a DNA sequence, which are arranged one after the another. A chromosome is a collection of genes. Okay, a population is also collection of the chromosome. Okay, now let us head to the fitness function. What is the fitness function? Is nothing but it is an evaluation of the population. It is going to find which one is a toughest one or the strongest one. It will assign some score to it. Based on that score, we can judge that okay, this individual is a fitter one or the one is we can reject. Okay, so what is fitness function is individuals evaluated in every iteration based on their fitness scores, which are calculated by the fitness function. Okay, so and individuals with higher fitness score represent a better solution and are more likely to be selected for crossover and passed on to the next generation. Here in every concept in genetic algorithm, it is our main aim is to select the fittest one, fittest individual, so that he can pass his characteristics to the next generation. So the fitness function is nothing but it is an evaluation criteria. Here you can see in the diagram. For example, if you can assume these all are basic chromosomes. Okay. So out of these chromosomes, we are going to give a fitness function and we are going to apply the fitness function. And based on that, we'll get some scores. Okay. Then we'll select the top two as a breeding so that they get to breed and they get to reproduce and remaining are discarded. Here you can see that these top two are selected and remaining are discarded. These top two are going to breed and pass their characteristics to the next generation, and generally most of the time the next generation is better than the previous generation. Let's understand some operators used in genetic algorithms. Basically, there are three operators which are used in genetic algorithm. One is selection, crossover, and mutation. Okay, what is selection? Selection is nothing but selecting a fittest person or an individual or a gene out of population. So that is called selection. Now we can see the definition here is selection is so after selecting the fitness of every individual in the population, a selection process is used to determine which of the individual in the population will get to reproduce. This is nothing but out of the population, we have to select their fitness function. Then after that, we'll select the one who has the highest fitness score. So there are basically many selection operators, out of which three are popular, like roulette wheel selection, tournament selection, rank based selection. In roulette wheel selection, what happens? There is basically a wheel, okay, which generally select the one who has the highest probability. Okay, for example, if there are 5 members, out of which A has a like a 50% of the strength, then there is the probability is that when the wheel is rotated, the person of getting the highest probability is that A person. He has a 50% of the chance to get selected. This is all about the roulette wheel selection. And tournament selection is that nothing but we are out of, for example, if there are 100 samples, 100 population, out of which I will make a group of 10 people in each group. Then out there will be 10 groups. Then I will conduct one tournament, out of which the one who comes the first in each group, then I will select the 10 individuals, and thereafter we will proceed for the further steps. This is about the tournament selection. Rank based selection is we will assign a rank to the individual based on their fitness function. Then again, it is nothing but it is an improved version of the roulette wheel. Then again, we will rotate the wheel. Then we will select the highest probabilistic person. Generally, the highest probabilistic person is going to be selected. So this is about the selection. Now let us see the crossover. Crossover is nothing but in general biological term, it is a mating. Okay. In general, two individuals from the current generation are chosen and their genes are exchanged to create a new individual representing the offspring. This is nothing but a reproduction. Okay. So generally two individuals are going to be selected. Then after that, when the twos are selected, they are allowed to exchange their genes and then they will produce a new child. Okay. This is all about the crossover. And basically, there are typical many. There are, but these three are three crossover operators. like 1-point crossover, 2-point crossover, and uniform crossover. Basically, what is 1-point crossover? Okay, 1 point is that you can see that this is the one line we have drawn it. Okay, out of which we are going to exchange the genes. Okay, to the other position. Okay, this is known as 1-point crossover. For 2-point crossover, what will happen? There will be two lines. Okay, this you can see these two lines. Okay, one more line is down here. Okay, out of which in between the lines, whatever the genes are there, their values are going to be exchanged. Okay, this is known as 2-point crossover. What about the uniform crossover? Uniform crossover is nothing but the whole chromosome is selected and it is exchanged with another chromosome in a uniform way. Okay, if 0 is there, then 1 is there, then 0. Like this, we are going to exchange in a uniform manner. So 1 point is nothing but 1-point crossover is nothing. One line is drawn here. Okay, 2-point is nothing but the two lines are drawn here, and the uniform crossover is nothing but the whole value is exchanged with another chromosome. Okay, this is about the crossover or mating. So now let us understand what is mutation. Once we have a selection, then after the crossover, then we do mutation. Mutation purpose is to add some extra qualities to the generated child. Okay, so mutation is a random alteration to a chromosome that results in the development of a new pattern. So this is known as mutation. That is nothing but, for example, if I say after crossover, I have selected this chromosome. Okay, then what I will do, I will additionally do the mutation here. I will change this randomly. It will select any one of them. Okay, it will change the value from 1 to 0, for example 0 to 1. Okay, typically there are three operators in mutation. That is, one is flip bit mutation, Gaussian mutation, and swap mutation. Flip is nothing but it is going to flip the, if 1 is there, then it is 0, otherwise 1. Swap is it will exchange. Okay, that is known as swap mutation. So this is about the mutation. Now let us see some overall how this crossover or mutation and everything is happening in this image. Okay, so crossover is nothing but this is like 1-point crossover. Here I have taken one example. As I said earlier, you can do 2-point crossover or uniform crossover. It is a trial and error basis. Okay, it algorithm will select. Okay, so here I am doing 1-point crossover. What I will do is I will exchange the position of the genes. Okay, like this crossover, I will interchange it. Okay, this is known as crossover, crossing each property to either one. Okay, then after that mutation, as I said, flip bit mutation or swap mutation, like this, I will randomly select any one of them. Okay, or many. Then we will try to flip or swap. We will change and we will add an extra property to the chromosome so that it may become, or it will become, a more versatile than its parents. So this is a basic representation of crossover and mutation. So now let us head to the basic flow of a genetic algorithm, how it works generally. Here I have written the same steps, so I will explain it here in the figure. So first we will initialize the population. Okay, first we begin, then we will initialize the population. After initializing, we will calculate the fitness value. This is not based on the fitness function. We are going to calculate the fitness value. One fitness score will come. Based on the score, we will select the one who is having the highest score. Okay, based on the roulette wheel selection and others method. Then after the selecting the person or the individual or the chromosome which has the highest fitness score, then thereafter we will do the crossover. After the crossover, then we will do the mutation, like flip mutation or swap mutation, like that. Okay, after the mutation, we will see, okay, whether the what are the individual or the gene or chromosome which we obtain has satisfied our criteria or not. Okay, if that is if that criteria is satisfied, then we will end this algorithm here. Otherwise, then we will go back to this initial population steps. Then again we will try to repeat this process until and unless our criteria is not met. Okay, so this is all about how genetic algorithm basic diagram flows. Okay, the same steps I have mentioned in this. So now let us head to some advantages of genetic algorithm. As I said earlier, genetic algorithm works parallelly while we are comparing with the traditional algorithm. Means we can simultaneously work with many problems so that we can solve the problem. So the second one is global optimization. Global optimization, why it is called a global optimization? Because we can optimize many problems like in many fields using this genetic algorithm. Genetic algorithm mostly used in many fields, like we can say AI field, economic field, sensors field, many field. It can be generally in medicine field. It can be used. So Global optimization is possible using genetic algorithm, and also it gives a larger set of solution space. Okay, this is one biggest advantages of genetic algorithm. And generally it is a probabilistic in nature. Why it is called probabilistic? Because you can guess, okay, generally the fittest one will come out of the every parent, then the child has a better property than the previous one. So you can guess, okay. So this is why it is known as a probabilistic in nature. And also it works well on discrete or continuous problem. Okay, for example, machine learning works well on continuous data. If it is discrete data, then you have to do so many pre-processing and other things. To the contrary to that, genetic algorithms works both well on discrete or continuous follow. And also, see, this is the one of the biggest advantages, good for noisy environments. When there is a noise in the environment, then also it works well. So these couple of advantages are there. Why it is why, so that we can understand why genetic algorithm is very popular in every field. Okay, now let us see some disadvantages. Okay, see, genetic algorithm is, it is like an art. So we have to first basically understand the art, then we can try to implement it. So typically, still a genetic algorithm implementation is still an art. Okay, and genetic algorithm is slow for training generally because it has to calculate or it has to select each individual fitness score. Then based on that, it has to evaluate, then crossover, then mating, then we have to select, we have to check whether this criteria is met or not, then otherwise we have to repeat it. So generally genetic algorithm is slow in training. Okay, and genetic algorithm is because we have to select everyone, or we have to cross check with every individual, then this becomes expensive. So in the same manner, the computational complexity also increases, and there are so much computational complexity, then it is difficult to debug and even to understand how the process is going on. And all of, because of all of this reason, optimization is also becomes challenging. So these are the main disadvantages of genetic algorithm. Now let us see some use cases. Okay, so nowadays use cases of genetic algorithm is that it is mostly touched all the fields. Okay, you can see it here. Mainly in machine learning algorithm you can use for hyperparameter tuning or pipeline optimization or feature selection. Feature selection is one of the important steps in machine learning, if you know that. Okay, selecting a proper feature, which one is useful to our model training, which one is not. Okay, we can select, you can, or you can use genetic algorithm for the feature selection. Okay, pipeline optimization, like optimizing pipeline is very critical nowadays. Okay, otherwise the ML model efficiency may drop. And also hyperparameter tuning, to selecting out of many parameters which one is the better one. So here also we can use hyperparameter tuning. So basically, in machine learning algorithms, we can use this genetic algorithm in very vast way. And also in our general case, okay, for generally everyone knows that for vehicle routing, we use Google Map or any other. Okay, from going from point A to point B, we will come to know that which is the shortest path. Okay, the app automatically select. But in behind the process is that mostly genetic algorithm is working. So this real use case is that we can use for vehicle routing. Okay, after that in medicine field it is used for selecting a better protein or the fittest protein, or the predicting the better DNA, or the predicting the fittest DNA, or like, or even predicting the better medicine for selecting for other experiments. So in medicine also it is mostly well used genetic algorithm. And in robotics, generally in robotics how it works is, like for example, generally robotics has its arms, okay, arms or legs or whatever it may be, wheels maybe. Even in that case also, how an arm should move from point A to point B. Okay, how, for example, if a robot want to select an object from its initial position to the target position, how it should go. So all this we can use a genetic algorithm, and after that we can use in economics. Economics is used like to manage the supply and demand issues, or scheduling the task. After economics, we can see that wireless sensor networks also we can use. In this case, for example, for routing, okay, we can use which path is the better one, and also for consumption, electric consumption optimization also we can use genetic algorithms in wireless sensor network. So not only this, there are many apart from this. I have listed few. So you can understand that genetic algorithm has its very vast usage and applications. So this is all about genetic algorithms. So we have seen today.